Okay, section 6.2 is on the law of cosines. So same idea, we have a triangle that is not necessarily a right triangle. And remember, you can't always do law of sines, right? So we need a backup plan. What can you do if it's not a law of sines problem? So I'm going to try to pretty quickly explain where law of cosines came from for those of you that are interested. So say we have this non-right triangle, but we always like to draw the height in there. I should just use the pencil because the straight line doesn't like me. Call that H. That splits the bottom and not in half, but into two pieces, right? So if I call this piece X, the whole thing's B, so this piece would be B minus X, the leftovers. So now we have some right triangles that we can do some math on, right? One of the things we like to do is Pythagorean theorem. So on the right side, I'm going to do Pythagorean theorem. So hypotenuse squared is equal to leg squared plus leg squared. So we don't like having parentheses squared there. So if I do the math, which is probably an area diagram for a lot of you, that's going to give me a squared equals h squared plus b squared minus 2bx plus x squared. Do an area diagram if you don't believe me. Now if I look at the left side of the triangle, so the left triangle, I should say, I can do Pythagorean theorem there as well. Hypotenuse equals leg squared plus leg squared. Well, remember, h was never actually part of this picture. I want to be able to get rid of that h and still be able to solve this. So let's solve for h squared in this equation, c squared minus x squared, and let's substitute it into the other equation. Right? I want to get rid of everything that was not actually part of my original picture. I've got some simplifying to do. The negative x squared and the positive x squared go away. And now we've got it almost all the way down to just the original a, b's, and c's, right? I added the x's and the h's. So to get rid of that final x, remember x is on my left triangle, we need to be able to find another way to replace x. Well, cosine of a is x over c. So if I want to replace x, solve this for x, cross multiply. X is equal to c cosine a. Now I can replace that there. So a squared equals, I'm also going to put this in alphabetical order because that's how I prefer it. B squared plus c squared, same thing, right? Minus 2 times b, because that's there, times now I'm replacing it with c cosine a. So neatening this up, a squared equals b squared plus c squared minus 2bc cosine a. And that is one, the top one actually, of the different law of cosines depending on what you are looking for. Please understand it is all the same formula, but it's based on the endpoints. So like if I was concerned about finding lowercase b, I would use this equation because it ends in the b's, etc. This is where it comes from. Now we're going to put it into practice and start using it. One thing I forgot to mention over here, you probably want to highlight this. If it's a law of cosine problem, only one triangle exists. You will not have to try to find a second triangle. There's only one way for this to be possible. So set up your picture. Hopefully you're getting better at setting up your pictures. Mine always look the same. Important part is where you label things. Not necessarily the capital letters, but the lowercase letters. So if they give me little a, that's across from capital A. They give me little b, that's across from capital B, and little c is across from capital C. So they give me side, side, side. So if I was trying law of sines, I don't have a perfect full ratio, right? I don't have A, I don't have B, etc. So law of sines would not work. Honestly, I always try law of sines first. So this must be a law of cosine problem. You could choose anywhere to start on this one, right? Because it's all the same, side, side, side. I am going to choose to start with A, just because. So if I'm trying to find angle A, I want to start with the A squared equation. So 45 squared is going to equal, it starts just like Pythagorean theorem, right? B squared plus c squared. Don't forget the minus 2 times both of those times cosine a. And that's what I don't know, right? So I'm just going to put an a there. So you want to carefully start solving this for a. I highly suggest you write it all down, because if you just start pressing minus in your calculator and rounding as you go, you're going to get further and further from the exact answer. So first I'm going to subtract both of them, and I'm not even going to do it. I'm going to let my calculator do it, but later, right? So I'm subtracting the 32 squared and the 15 squared. Hopefully you understand what I did there. I mean, you could do the 2 times the 15 times the 32 if you want to, but I don't recommend it. So now I'm trying to get cosine A alone, so I need to divide by all of that. I can divide by all of it at once. So on both sides, divide by negative 2 times 32 times 15. So I like to put my cosine A over here. Cosine A is going to equal whatever 45 squared minus 32 squared minus 15 squared divided by whatever negative 2 times 32 times 15 is. So if I need angle A, you're going to do inverse cosine, second cosine of... Okay, here's where I'm going to start typing it the way you need to type it in your calculator. The top needs a parenthesis for 45 squared minus 32 squared minus 15 squared. You need to close that parenthesis, divided by. The bottom needs a parenthesis. I'm going to do negative 2 times 32 times 15 down there. If you type this in exactly as it's written, you should get angle A. Remember, we're going to have to save that for later. Type it in very carefully. Angle A should equal 143.933. Save it in A for later. One thing to make sure you're doing, this is the minus button on your graphing calculator. It is not that parentheses negative. That button on your calculator is the negative button. Make sure you are pressing minus for those. But this one over here, that is the negative button. So we need to start learning how our calculators work. Okay, so I found angle A. I should probably write it in my answer blank. As soon as I saw that it was not a law of sine problem, I could fill in all my triangle 2's. You do need to answer this, otherwise I will not know that you know that only one triangle exists. Once you find angle A, you can repeat the whole process for angle B. So now that I'm going to start working on B, I want to start with the B squared equation. So 32 squared equals... When you start law of cosine problems, you must stick with law of cosines. If you switch over to law of sines right now, you might accidentally create the extra triangle that isn't supposed to be a possibility. By the way, that extra triangle, it's called the ambiguous case, but it's not a possibility in law of cosine. So don't switch to sine in the middle of a cosine problem. Don't do it. Okay, so I'm at 32 squared. B squared, okay, equals A, well, that's technically C, plus the other one squared minus 2 times both of those times sine of B, because that's what I'm looking for. So the endpoints should match. This should be lowercase b, this should be capital B. Start solving it. I'm going to try to do it in fewer steps this time. You should get better. You don't have to do it in fewer steps, but you should be getting better at that. So I know I'm going to have to, first of all, I'm going to get sine B alone. It's going to be the 32 squared minus the 15 squared minus the 45 squared, and then I'm going to divide it by that negative 2 times 15 times 45. And then to get angle B, I'm going to do inverse, oh no. Why did I turn it to sine, you guys? Why didn't anybody stop me? Cosine. Law of cosines. Cosine inverse of parentheses on the top over parentheses on the bottom. See if you can get the right answer. good news is to get angle C, I just do triangle sum. I should probably store that in B, right? 180 minus button A minus button B will give you C. And then we should also practice finding the area of the triangle. Area is 1/2 side angle side. So, I don't know, 15 times 45. The angle in between them is angle B, which I happen to save in button B. It is sine for the area formula. And you should get an area of 141.294. Okay, see if you can draw and set up example 2. On test day, we're not going to tell you if it's a sine or cosine problem, right? Now you know 2 different ways. It's up to you to be able to figure out which type of trig, law of sines, law of cosines problem it is. So once I finish drawing this, I check, do I have a partnership? An angle and its opposite side? Nope. An angle and its opposite side? Nope. If I can't find an angle and its opposite side, it is a law of cosine problem. Also, if I have 3 different letters in the given, it is a law of cosine problem. This time it's not side, 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 right? This time they gave me 1 angle. The only option here is to solve for lowercase a first, because I need that opposite angle in order for the equation to work. So you should be starting with a squared. Then I basically have a by itself. To get a officially alone, you need to square root it. So you're going to type it in all at once. You type the square root symbol, it'll either start a parentheses or it'll keep you underneath it unless you press the arrow button. You type it all in, and it should give you little a is approximately 21.255. Store that for later. 21.255. Notice the order of the answer blanks is not always the order of the things you find. Because this was a cosine problem, second triangle does not exist. And do not switch to sine in the middle of a cosine problem. So now that you know little a, you can start solving for angle B. So, I mean, you could also start solving for angle C if you wanted, but B squared, since I'm moving on to B. How about 15 squared? Sorry. 15 squared is going to equal, I know 10 squared, and now I have to use my button A squared minus 2 times 10 times button A times cosine of angle B. I need to get angle B alone, so this is more like the other one, right? I'm going to get cosine B alone first. I'm going to do 15 squared minus the 10 squared to the other side minus the a squared to the other side, and then I would divide by negative 2 times 10 times a. So then I'm going to do inverse cosine, parentheses on the top, close those parentheses, divided by parentheses on the bottom. And then you should get angle B to be approximately 39.761. And you should store that in button B for your calculator. And since we know 2 angles now, angle C is going to be triangle sum. 180 minus 115 minus button B. Angle C, when you're done, should be 25.239. If I'm going too fast for you, you need to pause the video. That is part of why we are making videos, so you can pause it and try it on your own and then press play to see what the answer is. Why don't you find the area? Pause it and find the area. When I do go to find the area, I make sure I use, whenever possible, the given numbers. Remember, area is side angle side. We have side angle side in this problem that were typed onto the test. So I'm going to use 10, 15, sine 115. The area formula is always sine. The area for this ends up being 67.973. Okay, our final thing for today is Heron's formula. Heron was a Greek mathematician who lived around 100 BC, and he found a way to find the area of a triangle just by using the side lengths. So never knowing any angles, never doing any trig. I'm not going to prove this one to you. I feel like I've proved or derived a lot of these for you. You're always welcome to Google anything and see for yourself where it comes from. But for now, we're just going to believe this one and just do an example. It's another way to find the area of a triangle if asked to find the area of a triangle on the test. So notice that S is the semi-perimeter, half the perimeter. So in our example, we need to start by finding S. So we're going to do 8 plus 13 plus 15 and divide that by 2. If you do that, 21, 36 divided by 2, you're going to get 18. So our area is going to be the square root of 18 times 18 minus 8 times 18 minus 13 times 18 minus 15. So our area is going to be the square root of 18 times 10 times 5 times 3. At that point, actually even the step above, seems like a good time to type it into a calculator, and the area is going to be approximately 51.962. I guess this problem is centimeters squared. So there's another way for you to find the area if that's all you're asked to find. Usually ours are going to be more like this, right, where we have to find everything. And if you have everything, the sine formula seems a little easier to me just to memorize. But Heron's formula is a choice. Hope you guys are doing well.